What do we have to do to make this thrive? Not just survive, but thrive.
Let's go. Let's go to space. Okay, great. Well, welcome everybody. This is Fridays with Tim. We're going to go ahead and get started. And we're doing things a little bit differently today. We've had a lot of requests to record these sessions and then make them available for people to watch later. So last week we covered a lot of additional information. So today I'm going to recap some of the things I talked about last week, and then stay tuned. There's some new stuff at the end, and then we'll go into our normal Q&A. And since this will be the first video in the series of Friday with Tim's that we post on our YouTube channel and other places, I did want to just introduce myself and Orbital Assembly Corporation for anybody who may be new. My name is Tim Alatorre. I'm the Chief Operating Officer and Chair of the Board for Orbital Assembly Corporation, or OAC. And OAC is leading the race to make space available to everybody by building the Voyager class of space stations, which is the first gravity simulating on-orbit habitation environments for leisure, commercial, and industrial activities. We've defined a number of revenue-generating development milestones, which I'm going to cover in a minute. And we're able to serve commercial, research, military, and government uses, as well as we've identified several marketing opportunities prior to the first Voyager station development or deployment in 2027, which we'll be talking about as well. And our proprietary designs, as if you've seen our graphics, they're large, they're modular, they're scalable, and forward-feeding to subsequent and next generation stations, which is one of the things that really gets me excited. Our station designs are not one-offs. The technology and the work we're doing now carries forward into subsequent designs. So let's get going. I'm going to do a recap, like I said, of what we talked about a couple weeks ago, just to catch everybody up, and so we're all on the same page. First thing, back in July, our whole team went to Space Fest, and it was not only a lot of fun, but we were able to give a presentation with one of our strategic partners, Rogue Space. Jeremy was there, the CEO, and we were able to speak about artificial gravity stations and the future of space construction. And also we were able to establish a lot of good industry partnerships and meet in person with some of the people we've been meeting on Zoom. So while these kind of events are fun, it's also a really important business development platform that we're able to utilize. And thankfully, some of the restrictions of COVID have been lifting, so we can do these in-person events again. And following just in the heels of that, last month in August, Rhonda Stevenson, our CEO, was able to go to Space Symposium, which is arguably the biggest US-based space industry event. And she was able to further some of those strategic partnerships and had a lot of really key meetings. In fact, she even ran into the CEO founders, I should say, of Sierra Space. And they were joking with her that they were fighting over our business card because it has a picture of Voyager Station on it with all of their little dream chasers on the perimeter. And Rhonda said, we need 46 of these dream chasers by 2027. And they said, don't worry, we'll have them ready for you. And they're super supportive of what we're doing. And we're really thankful for Sierra Space and their partnership. And then, of course, the big thing, which we talked about a couple weeks ago, was the NASA solicitation, the commercial LEO destinations request that NASA put out. And as you may know, NASA is looking to transition away from ISS really as soon as they possibly can. And they want to be able to lease space from commercial stations. Well, there aren't very many stations. The Chinese have one, the International Space Station, right? And so NASA, this solicitation, this proposal request was to provide some marginal funds to help companies develop the plans for stations, not actually fund the construction of them, but just the development of them. So we had a really, a robust, comprehensive team we put together to get this solicitation put together. And I just want to, thank a couple of people. Mae Jameson from the 100-Year Starship Project, United Launch Alliance, John Reed, Crystal Morgan, Sierra Space, John Roth, Fatih, and Aaron Osman. And then also Aldo Spadoni, who helped us with some of the graphics, and Paul Fuller, who helped us with the financial analysis, Sam Congligo, who helped us with writing and proofing, Elena Probst, and then of course our core team, Rhonda, Jeff, Tom, Rob, James, Tim, Clements. It was kind of an all hands on deck process for this. Plus, all of those partners who submitted letters in support of the project, we really are appreciative of them. Next, we unveiled 2 weeks ago our new Pioneer class of space station, which is an intermediary between our first launch in 2023 with P-Star and Gravity Ring and the full Voyager station. And some of the specs here are on the slide. We're really excited about it because we're going to be able to test the Voyager modules and the couplers, as well as artificial gravity research and start tourism 2 years earlier than we initially planned. And here's our development roadmap right here. So you can see here in 2023 we have our Pioneer class P-Star, which the P-Star Mark 1, which will build Gravity Ring, and we're going to have a whole assortment of commercial payloads on that. We have a lot of interest, which I'll show you in a second, for people who want to do artificial gravity research. We're going to build that trust, we're going to spin it up, create artificial gravity, and that'll be our first on-orbit revenue platform. And then that feeds forward right into the Pioneer class, the first Pioneer class station. We launched the P-Star Mark II in 2025, build the truss for that, and then the habitable elements, the modules and the couplers, those are Voyager class size elements, and so we can put those up, test them, run them through their paces, and also Pioneer Station allows us to be cash flow positive and fund Voyager Station moving forward through the income and revenue from Pioneer, which is very exciting. Everything feeds forward. So the modules, Pioneer class of station, we have a 4-module version, but if there's a market demand, we can also go and do a larger 8-module version. And then all of those components transition into Voyager Station, right? So all the modules and couplers feed forward right into that, which is really exciting. So here's a couple of the partners, which I'd mentioned earlier. We've been really working hard to develop relationships with different companies and financial, commercial suppliers in the aerospace industry, and we're really excited to have such a wide variety of interest and support. And Mae Jameson with the 100-Year Starship project has been very supportive. Sierra Space, as I mentioned, has been phenomenal. And then Rogue Space, as we announced earlier this year, is one of our partners on the P-Star and Gravity Ring project, and we'll be using their technology and their capabilities to help support our construction projects. And then, of course, ULA, Aerojet Rocketdyne. There's a lot of companies that have been really instrumental in helping us along the way, and we're very thankful for that. So that's a recap of what I covered 2 weeks ago. Now, we also have something exciting that I can share with you today. At the top of the hour, we actually have a new video that will be premiering on our YouTube channel. And this video is a sneak peek in preparation for another event, which will be coming up hopefully in a couple weeks. And I can't tell you what that event is, but you can go and watch the video. And if you read the description, it might give you some hints as to what we're up to next. So we're very excited about what's going to be happening in the next couple weeks. And also, we've contracted with a company who's going to make our P-Star and Gravity Ring, those graphics, available in an interactive 3D experience that will be on our website. And there's some cool things that we're going to be doing with that as well. So stay tuned, and we'll update you as things progress on these calls as well. So with that, I'll stop my screen share here, and we will open it up for questions. Let's see here, looking at chat. So just we are recording, and if you don't feel comfortable being recorded, you can turn off your video and just ask a question in chat. And there's a couple of late people. We'll let them in from the waiting room before we get into the Q&A here. So they're joining now. Chuck's asking, is this being recorded? It is now. Yes, Chuck. Yes, we are doing that. Okay. So Richard, he's asking, hey, Tim, thanks for addressing my question. I'm currently considering a career change, and I'd love to align myself on a path that could result in eligibility to act as a crew member on board one of your orbital platforms. I can't think of any projects that are as important for humanity's future, and I'd love to participate. Could you please speak about this? Yeah, thanks, Richard. And actually, we have a lot of people who, everybody on the OAC team is excited about this project, right? And a lot of you are, which is why you're here. And a lot of people reach out to us wanting to know how they can become involved in some capacity. In the near term, and I've spoken about this before, and I'll speak about it again. In the near term, our needs really have to do with engineering and design, and then starting next year, also on the fabrication side, and moving into all of that. As we move towards the 2023 launch, we're also going to be needing people to help with our mission ops. And then as we head towards our 2025 launch, we will be needing people to be crew on the station. On the Pioneer class station, we're estimating about, depending on the season, because for Pioneer, we're going to have gravity seasons. We're going to have probably about half the year where it's an artificial gravity station, the other half of the year where it's a microgravity station. So we're going to need crew who are trained, who will be on the station, and we'll have anywhere from 2 to 6 crew on the station at all times. And we'll be needing people to staff that. Once we get to Voyager, that one will be artificial gravity in rotation in artificial gravity pretty much the entire year. We'll probably stop it once or twice per year, empty the station out to do maintenance and things like that. But for the most part, our crew will be operating completely in an artificial gravity environment. So the barrier to entry for crew on Voyager will be a little less than Pioneer, where you're going to have to go through some additional training. But between here and Voyager, there's so many people we're going to need, lots of different professions and industries, clerical, office, hotel, kind of concierge type people, the crew who operate and manage the station. So if you're interested, what we're saying right now is send your resume to info@orbitalassembly.com. And we are recording all of those and saving all of those resumes. And then we're working on right now, actually, a number of job postings and listings. And so if you're in our database, you'll get notified of when those opportunities arise, and we can kind of go from there. So if you're looking for a career change, I would say do something you're passionate about. And if you want a really short-term job, look towards engineering and manufacturing. And long-term, over the next kind of 5-6 years, we'll be needing probably somebody from every sort of walk of life. Matthew is asking, how will the shuttles dock to the outer ring when the station is spinning? So they don't actually. On both Pioneer and the Voyager class stations, we never dock anything on the outer ring when the station is in rotation. For Pioneer class station, we actually won't be doing EVA, extravehicular activity, or docking when it's in rotation. Voyager station does have a system, the rail transport network around the perimeter, where we can do EVA and some activities outside the station when it's in rotation. But all the docking of craft would happen when the stations are not in rotation. So for Pioneer, what that means is if you're on station and you're a tourist, let's say you go up there for a week, when you dock, the station's not in rotation, you would come onto the station in a microgravity environment. Then once everything is secured, the station would spin up. You would be in an artificial gravity environment for most likely the duration of your stay. And then at the end of your stay, the station would spin down back to microgravity. You'd get back into the craft and leave. Now for Voyager station, the routine docking actually happens in the center of the station. We have a despun central hub. And so that central hub stops rotating relative to the approaching spacecraft. The approaching spacecraft can then dock. The central hub then attaches itself to the spacecraft, and both the craft and the central hub then spin up to match the rotation of Voyager station. And keep in mind, Voyager station isn't rotating any faster than about 1.5 RPM, which is just slightly faster than a second hand on a clock. So it's not like, those spin up and spin down operations are dramatic events. They're very slow. And in fact, on the video that is premiering at the top of the hour here, at the very end, if you stay for the very last kind of 20 seconds, there's an animation clip showing the station going from non-rotation to the full 1.5 RPM rotation rate. So you kind of get a sense of how fast that is. Mark is asking, where do you plan to source your habitation modules from? We are actually looking to build those in-house. So Tim Clements, who's our VP of manufacturing, he has a long multi-decade history of building very large structures out of aluminum, and primarily for the shipbuilding industry. And so we will be building all the pressure vessels in-house. Now, the components that go into the habitation modules, like the environmental control and life support systems, those on that partner list that we had earlier, we're working with, Paragon right now, but there's also other, ECLIS, environmental control life support systems, ECLIS providers, and they would be providing those more specific parts for the Habitation modules. And many of the components, besides the structure, that are in our Habitation modules have been developed and are in use right now on ISS. And NASA has a scale for ranking technology. It's called their Technology Readiness Level, or TRL. And TRL 9 means technology has actually been flown in its configuration that is ready for use in space, right? TRL 6 and above are kind of where we're looking for. Oh, TRL 1 is just, I got a great idea. I might have a white, a sketch on a napkin sort of thing. So for everything that's going into Pioneer and Voyager class stations, we're actually looking at technology that's at TRL level or TRL 6 or above. We wouldn't be inventing or developing those technologies other than, making the pressure vessels. Tim's asking, does Pioneer use the same modules as Voyager? The very short answer is yes. So the structures of those modules are the same dimension as Voyager station. They're Voyager class modules is what we're calling them. Now the layouts will be different. So the Pioneer class stations have a much tighter radius. So the floors, the curvature of the floors they'd be installed at a different radius to match the radius of the station, where Voyager would have much flatter floors. Because you remember when you're in rotation with artificial gravity, your up is towards the axis of rotation. So as that axis moves down closer to where you're at, and you move to the edge of the modules, your up is more towards the center of the module. So we would fit out the modules differently, because also the Pioneer class stations are also going to be outfitted for microgravity use as well. But the structure, the connection points, those are all going to be identical. And so it's an easy transition from one station to the next. And in fact, we can even with like the Pioneer station, I showed the 4-module version and then an 8-module version. If there's enough demand and people are really enjoying the Pioneer class station, we can actually detach those modules and move them onto a larger truss. So we wouldn't have to relaunch 8 new modules to go to a larger Pioneer class station. We could detach the 4 modules, the 4 couplers, position them on the new truss, and then have the capability for additional gravity levels and more occupants. So everything, like I said, is modular, is forward feeding. We're looking to make things very plug and play to where we don't have to keep launching new assets. And in fact, you could theoretically take a Pioneer class module, even with the floors at a different curvature, move it onto a Voyager class station, and then retrofit it on orbit to work for that different radius. Looks like we got Sebastian from Austria. Thanks for joining us. Matt's asking again, where can I send my resume? So the email you want to send it to is info@orbitalassembly.com. Let's see, Albert's asking, are you active on the OAC space subreddit for questions? Yes, there is an official OAC subreddit, and we've posted a couple things to that. So if you want to go ahead and post to that, we are monitoring that and happy to answer questions there. Kyle Sims is asking, are you planning on using 3D printing for some or all of the truss? And I just saw Aiden's got your hand raised, so Aiden, I'll get to you next. Are there any other companies that are also planning gravity stations? Thank you so much. So Kyle, initially, we will probably not be using 3D printing on, for example, the Pioneer class station. The technology really isn't there yet for doing anything meaningful other than creating some small basic components, which really doesn't save us much for launch. We actually have a excess of launch capacity. When we're looking at the different launch vehicles that we want to use, there's a lot of extra mass that is able to be lifted with these launch vehicles. And one of the things we're going to be doing is not letting any of that go to waste. We'll be selling that space to other companies in rideshare. And also, we'll have the opportunity to take up spare parts, water, food, other essentials. So in the short term, 3D printing probably won't be used. We have explored the concept of 3D printing, not this image here, but there's another rendering we did a couple years ago now of a Voyager station habitation area, and the furniture in there is all 3D printed. And the idea was that some things, like tables, chairs, they take up a lot of volume, not so much mass. it'd be easier just to send up a bunch of raw material and print those. But that's not something that is in the near-term roadmap, but definitely a technology we're watching and following. We've also been asked, just since we're on oh, and actually, Kyle, it looks like you're asking about the truss. So none of the structure is going to be 3D printed. All of the components are actually fabricated and assembled on Earth, and then they're assembled on orbit. And when we release this 3D interactive video model of the P-Star Mark I and the gravity ring, you'll be able to actually see how that whole sequence works. And if you saw our D-Star demonstration, it's basically that same process. The P-Star gravity ring is about half that size. If you watch the video about actually that demonstration, we talk about that we were going to do gravity ring at a quarter scale of the D-Star demonstration. We've now upped that. It's going to be 1 meter by 1 meter. So we're at a half scale of that D-Star demonstration. But 3D printing would not be used for the structure. We have been following that technology closely. There are companies, I'm sure you're aware, that are 3D printing aluminum, and we're watching that space, but not in our roadmap right now. We're on a very tight time frame. I can't wait for technology to be ready. Yeah, just one thing to note also, all of the little the space planes on the outside of our Pioneer and Voyager animations, those are Sierra Space Dream Chasers. So Dream Chaser is a plane that's in development. It's Sierra Space has a contract right now with NASA to deliver cargo to ISS next year using their Dream Chaser craft, and that's what those are. Okay, Aiden, thanks for being patient. You have a question? Go ahead and unmute.
Of course, thank you. My question was, how will orbital assembly prevent collisions with other satellites and other objects in space?
Yeah, so the question is, how are we planning to prevent collision with other objects in space? So there's two main classes of objects in space, right? There's those that we can track and those that we can't track. So I think your question is really more about the ones that we can track, and those tend to be the larger ones. And so actually the United States government, through the military, has a very high level, they got a big database where they're tracking all these things, and that data gets fed to NASA and other people who are operating spacecraft. And so we would use that same data feed to maneuver our stations to avoid those larger pieces of either orbital debris or other spacecraft. And usually you would need, you need some warning to be able to get out of the way. Then there's the smaller debris, which is not able to be tracked. And so just like ISS, we have what's called Whipple shielding and other shielding on sensitive parts of the station, to where if a smaller particle hits the station, it actually fragments and dissipates the energy so it doesn't rupture the pressure vessels. And so using a combination of active and passive defenses, we would protect the station. Let's see here, looking at the chat again, we got about 5 more minutes and we'll wrap up here. So so someone's asking from an iPhone, what might it cost for a week in space? It is a little early to say. We do have some numbers in our pro formas of what we expect the cost to be. The real determinant factor in there is what launch costs are. And so until we get closer to actually booking flights, we've been hesitant to say what those costs are. I know, a couple members of our team in the past have thrown out some numbers, but those are subject to change. So I would say stay tuned. But our goal, especially with Voyager Station, is to get it to where the average person can go to space, and you don't have to be a billionaire or a multimillionaire to go. And looking at the launch vehicles that are in development right now, we anticipate that being very likely and possible within the next 5 to 10 years. And so we're doing everything we can to make space accessible for everybody. There's been a lot of talk in the news about the billionaire space race. Orbital Assembly Corporation, we see ourselves as the everyman space company, right? We want everybody who's ever dreamed of going to space to be able to have that opportunity. And we've also talked internally about, programs that we'll be developing and working with partner companies as well to help subsidize those costs for people who, don't have the same economic opportunities to be able to go to space, and not just go to space to clean tables and work, but also, you know, go to space to do something that they're interested in, whatever that may be. Let's see. Tim Hester is asking, are there airlocks at both ends of every module? Yes. And we're also looking at some other technologies as well that we're developing, and I don't want to talk about them yet because we're working on getting them patented, to provide for additional safeguards within the module in case of a catastrophic failure. David says the habitation modules appear rather large. Will you have to assemble them after launching them? I believe you considered inflatables, which seems to be a simpler choice. So yes, they are large, and they will be the largest habitation modules ever put on orbit. This rendering actually right here that you see behind me is an earlier version of Voyager Station. We've shrunk the modules a little bit just to deal with the issues of logistics, but they still will be the largest modules on orbit. We have looked at inflatables, and in fact, we've had a couple of companies who've been really pushing us to purchase their inflatable habitats. The challenge with inflatables is if there was a situation where you had a catastrophic failure, let's say the inflatable was punctured and you had a leak, then that whole structure deflates, and if the station's in rotation, you're going to have a really hard time repairing it, getting out of there. There's just a lot of life safety issues that go into dealing with inflatables in a rotating environment. Now, I have seen other videos and things where people have, you know, talked about what we're doing, and they say, well, you could do the inflatable, you know, in the direction of, you know, pointing out from the axis of rotation to where it's pointing down. You still have that same issue. But yeah, we've looked into it, and we've just decided that it's not a workable technology at this point. There's an easier path forward, which is what we're doing, making the modules rigid and launching them. Okay, Aiden, looks like you've got one more question. You'll be our last one, and we'll wrap up for today. Go ahead.
Okay, okay, thank you. My question was about the Pioneer class station, the Voyager class station. Can they be modified for deep space travel? And if so, is there any plans to do this currently?
So the question, if you didn't hear, was, can the Pioneer and Voyager class stations be modified for deep space travel? Yes, theoretically, they could be, absolutely. And are there plans for that right now? No, it's not in our roadmap. The graphic I showed earlier was, you know, going out to 2025 with the Pioneer class station, and then 2 years after that, Voyager station would come online. So right now we're in a dead-on sprint to get Voyager up and running in the next 6 years. And you know, once we have the Voyager platform operational, then we can start to look at you know, those next steps. And actually, I'm sure we'll be looking at those next steps before we get to 2027. But right now, we're focused really on LEO, and there are some complications, primarily with radiation shielding when you get into deep space. But those are all you know, you can overcome them. Okay, well, with that, we will wrap up. And you know, just a reminder, we're going to be doing these, trying to do these every 2 weeks, and we will be posting this onto our YouTube channel, the edited cleaned up version where we don't have all my mistakes at the beginning, the technical issues. And we look forward to having you guys back in the next couple of weeks. And yes, you can reach out to us, info@orbitalassembly.com. Yep, that's the address. If you have a resume or you have a question. And also, as was mentioned, we do monitor the OAC Space subreddit. You can also reach out to us on Twitter/OAC Space, on Facebook, on Instagram. We're trying to be more responsive. So thank you all, and we'll talk to you in a couple weeks.